Have you interacted with a computer today? Even if you have not opened a laptop or checked emails on a desktop machine, the chances are high that you have. Your smartphone is a computer, so is your ebook reader. Computers are embedded in your car and on the city streets you travel. The building where you work or study may rely on computers to manage lighting and climate control. In truth, computers surround us in ways we rarely notice. Computers come in an enormous range of shapes, sizes, and capabilities. At one extreme are supercomputers that may occupy entire rooms. At the other are handheld gadgets like smartphones and media players. Between these extremes sit desktop units, which are stationary and capable, and laptops, which balance portability with performance. The primary distinctions between handheld and desktop or laptop systems include the types of peripherals available, the amount of RAM and storage, and the availability of external storage options such as USB flash drives or optical disk drives. So, what makes a computer work? At its core, a computer is a programmable electronic device. For it to execute programs, it needs several key components: a central processing unit to carry out its instructions, memory to temporarily hold programs and data during operation, input and output capabilities for user interaction, and long term storage and networking capabilities. This definition extends beyond traditional desktop and laptop computers to include servers, mainframe systems, supercomputers, gaming consoles, smartphones, and e-readers. The latter two categories are more specialized, running only a limited set of applications. The era of the computer as a single identifiable machine is gone. Today, computing is woven into the fabric of everyday life. The processor is the central component of any computer. Its role is to execute the instructions that make up a program. For software to run on a specific computer, it must first be compiled for that machine, a process that translates a program written in a high-level language like Python or Java into the computer's native machine language. Only code written in that machine language can be directly executed by the processor. Computers rely on two distinct categories of storage: short term and long term. Short term storage, commonly known as RAM, random access memory, exists in several forms. Modern computers typically use three types: dynamic RAM, the main memory, static RAM, used for cache and registers, and ROM, read only memory. Main memory consists of chips that offer rapid data access and relatively high capacity. Some compact devices instead rely on flash memory, which is slower and more limited. Long term storage, typically hard drives, but also optical disks, flash memory, and magnetic tape, vastly exceeds short term memory in capacity. Desktop and laptop computers commonly have 1 to 8 GB of RAM, while hard drives can hold 1 TB or more. For context, 1 GB can store more than 1,000 text only books. Both storage types are necessary for practical computing. Long term storage houses large programs and data files, while short term memory provides the speed needed to run them efficiently. Without fast RAM, program execution would be painfully slow. Without long term storage, the system could not retain data when powered off. Volatile versus non volatile memory. So, a key distinction between memory types is volatility, whether the stored data survives when power is cut. Dynamic RAM and cache memory (SRAM) are volatile. When the computer shuts down, their contents vanish. This is why a computer must go through a startup or boot process each time it powers on. Now, non volatile storage, such as ROM, flash drives, hard disk, and optical disk, retains its contents indefinitely. ROM is permanent by nature. Flash drives and disks retain their data until explicitly erased. Peripherals are devices connected to the computer but located outside the main system unit, the box that houses the motherboard, CPU, and internal drives. Peripherals include input and output devices, keyboards, mice, monitors, printers, speakers, stylus tablets, and others. These input output devices are what allow humans to communicate with the computer. Without them, a computer might process data in complete isolation, useful in automated pipelines but inaccessible to the everyday user. Among the peripherals are communication devices. These allow a computer to exchange data with other computers. Typically, these are modems, either wired, connecting through telephone or cable TV lines, or wireless. Most modern laptops include wireless modems, while desktop may use wired or wireless options. In networked environments, computers also use network cards, such as Ethernet cards, to connect to a local area network, LAN. These cards support far higher data transfer rates than conventional modems. So, a complete computer system typically includes the following components: system unit containing the motherboard, CPU, cooling unit, RAM, ROM, ports, expansion slots, ROM BIOS, disk drives, fans, and power supply. Monitor and keyboard, a pointing device such as a mouse or trackball. Speakers, a modem or network card, usually installed inside the system unit. A printer, which is optional. Then, an external storage devices such as portable hard drives or tape drives. Hardware alone does not make a working computer system. Without software, there would be nothing to execute. Without users, there would be no one to direct the machine or make use of its output. A complete computer system therefore comprises three independent elements: hardware, software, and people.